it shows an open cylinder. It's actually a cylindrical container. And it is made of metal with a circular base and a uniform thickness throughout. The length of the container from the top to the bottom is 120 cm. The inner and outer radii are 14 cm and 15 cm. Now, first question is draw the cross-sectional area, or I would say the cross-sectional view of the container. Okay, now let me show you how the container is actually drawn in the figure. So you have this in the figure. Okay, figure is not the scale. Now, if I were to drop this, so we have the circular base, and then the distribution is in this fashion. So this is directly corresponding to the inner circular section, and there is a drop like this. So you have two cylinders actually enclosed. Okay, there are two cylinders that have been enclosed, and this is a rough figure. Okay, now this distance from the top to the bottom, this is given as 120 cm. Okay, with this being given, we are asked to draw the cross-sectional view of the container. So I'm going to use this instrument. So there are two diameters involved, the inner diameter and the outer. So it's better that you use this instrument, the compass, in getting the cross-sectional correct. Okay, so now this is the center. Now the inner radii is 14 cm, so this is 14 cm. The outer is given as 15 cm, so this is given as 15 cm. 15 cm, 14 cm. Okay, so that is the cross-sectional view. So this is the completion for this question. Okay, now as I mentioned to you, this entire length is given as 120 cm, right? Now this is the inner container. Okay, now you see this, the inner container is actually ending right over here. Okay, this is the point in which the inner container is actually ending. Okay, so there is a 1 cm distance between this point and this point, so we will have to cater that height. Okay, because this inner container's height is not 120 cm, it is actually 119 cm, because it is starting from the top and it is ending right over here, which is 1 cm from the bottom. But this is given in the figure. From the figure you will be able to see it. Of course, I have done a rough sketch, but the question paper's figure is more perfect. Okay, so that would be, it would help you in understanding what is the shape of the inner cylinder. Of course, from the picture's depiction, we can clearly see that the height of the inner cylinder is 119 cm. So having mentioned you that, let me move on to the second part of the question. So I explained you this height is because the second part of the question, it wants us to calculate, find the, okay, or I would say show that the capacity of the container, right? When we talk about the container, this is the container we are talking about, okay, is equal to 73304 cm cubed. So we have to show the container's volume. Now volume of the container, it's cylindrical in nature, so we have to use the volume of the cylinder, which is pi r squared h, which is going to be pi times 14 is the radii, so 14 squared times height is 119. So you will have to multiply 119. I'm going to multiply by 14. If you have a calculator, you can use the calculator. I will be doing mechanical way of extracting. So 9 4s are 36, 3, you have 7, 4, 9 1s are 9, 1, 1, 6, 16, 1, 6 and 1. Again I multiply by 14, 6 4s are 24, 2, 24, 26, 2, 24, 26, 2, 4 so 4, 5, 6, and you have a 6 and followed by 1. So you have 4, 12, 12, 13, 1, 12, 13 and 1, you have 2, right? So the value is 23324. You have to divide by actually 22 over 7. But to evaluate this, you will get the volume to be equal to 73304 cm cubed. Okay, so that's a conclusion for this question. Now we will have to determine the volume of the material. Okay, so for that we will have to get two volumes. This is going to be with the height, so this height is 119, but we will have to find the volume with height to 120. So let me do that. So that's going to be the external volume of the cylinder. We use the formula pi r squared h. So in this case it's going to be pi times the radii is going to be 15, so 15 squared times 120. So if you were to evaluate, you get 84857 cm cubed. So therefore I hope you're watching it, volume of the material, therefore the volume of the material used is equal to external volume of the container. From that you subtract the internal volume of the container. So external volume 84857 minus 73304. So in fact this has a decimal, so if you evaluate this, because pi is equal to 22/7, you will have a value of 84857.14. So this is going to be 0.14. So if you subtract these two, you get 1155314. Okay, cm cubed. So this has a decimal point. So if you're using calculators, you'll be able to get this off easily. So with that, we move on to the next question. This is the next question. We have to determine the mass in kg of the empty container. Now, for getting the mass, we will have to use this formula. Mass is equal to density times volume. Okay, now the density is given as 2.2. The volume is 11553.14. So the mass, if you multiply these two, you will get a mass of 25416.91 G. But we need in kgs. So what we do is we will have to divide this by 1000. Okay, so mass in kg is equal to 25416.91 divided by 1000. The decimal point will move towards the left. So it's going to be 1 cancels the 0, 2 cancels the 0, and 3. So this is approximately 25.41691 kgs, which means you can actually write it as 25.42 kilograms. Okay, that's the solution for this question.